All right, hello and welcome. This is going to be our homework help video for March 27th. We're going to be talking about arc length and sector area today. Two pretty easy formulas. This should be a pretty quick one. Here's your do now. We've got a picture here of an angle, and in green we have a reference angle. We need to find the measure of this angle. So how far has this terminal side that I'm tracing right now been rotated from this initial side, which is hiding right along that x-axis? So first, look what unit our reference angle is given in. It's given in radians. So we want to give a final answer in radians. All right, and then we're going to follow this spiral, and each half rotation counts as pi. So that's pi radians. All the way around is 2 pi radians. All the way around to right here is 3 pi. All right, if we kept going, I want to go over rotate this and then subtract that. We could say that at 3 pi, we're really at 6 pi over 2. All right, each quarter rotation is a pi over 2. So 1, 2, 3, 4, 5, 6 pi over 2. If I go one more all the way 90 degrees, that's going to be 7 pi over 2. But then I want to back it up this amount of the reference angle. So my final angle is going to be 7 pi over 2 minus pi over 6. Multiply this first one by 3 over 3 to get a common denominator. 21 pi over 6 minus pi over 6 equals 20 pi over 6. And then can this be simplified? I can divide the top and the bottom by 2 and make this a 10 pi over 3 radian measurement. And then you always want to double check if that's a positive or a negative angle. The very first move we did with our spiral here was to go up. So that means this is positive. That was a positive amount of rotation. 7 pi over 2 to here, but then we backed it up pi over 6. All right. Goal today is to be able to understand the formula for finding arc length and sector area and to make a, no, I'm not doing that today. Just do that. I will say it will be important going forward that you've really studied that unit circle. Sorry we're not doing my paper plate activity. It's really fun, but you know, do whatever you got to do to really study that unit circle. It's going to help us a lot in this next 2 units if you can quickly convert degrees to radian measures, and also if you know those ordered pairs around the outside, that just automatically finds your sine, cosine, or tangent of an angle through a way I haven't described yet, but you just need to have that unit circle really down. All right, so here's your arc length formula. You can pause the video and add this to your notes. It's very simple, just S equals R theta. But this only works if theta is in radians. So if theta is not in radians, the very first step will be to convert theta to radians. But then after that, you can just get your answer really quick. So here I've got a slice of a circle, and I just want to know what the length of this arc on the outside is. Just that length S. So it's going to be a distant unit. We don't know if this is 3 inches, feet, miles, whatever. We'll just say this is 3 units in here, and we want to figure out how many units out here. So S equals R theta. Plug in what we've got for R, 3 times pi over 3. The 3's are going to cancel out there, and S is going to be equal to pi units long, which, you know, it's roughly 3.14. Now check for reasonableness. If this length here is 3, could that arc out there be about 3.14? And just imagine lying that arc flat over here. Maybe it would poke out a little bit extra. So very believable that arc is 3.14 units. Okay, here's another one. Sometimes it is written arc AB. Sometimes it's even AB with like an arc over it. This all, 2 different ways to say we just want to know the distance from this point right here to this point right here, walking along that curved path. All right, so S equals R theta. Can we just plug in these numbers and solve? Well, if you did that, you'd get a number that's way too long. Hopefully when you checked for reasonableness, you would catch yourself. But this 45 degrees is not a radian measurement. This has to be converted. So let's remind ourselves how to convert degrees to radian. You just have to multiply by a conversion that you know is true. The one that I've memorized is that pi radians is equal to 180 degrees. It's a really easy one to memorize. Here, this is going to be 45 pi over 180. The degrees have canceled out at this point. And then I can have 45 over 180 be simplified. I'm just going to do it in my calculator. I'm going to do 45 divided by 180. And then I'm going to hit math, enter, and it's going to turn it into the fraction 1/4. So this here equals 1 pi over 4. We don't have to write the 1. So that is our theta. And then the radius is 12. So now I want to do, let's get a different color, S equals 12 times pi over 4. Multiply that 12 to the top of that fraction. S equals 12 pi over 4. We can complete the division here. 4 goes into 12 evenly, so this is just 3 pi units. And then I'm going to actually type in 3 times pi in my calculator to get that that's about 9.42 units. Let's check to see if this is 12. Can we believe that that length there is 9.5? Looks about right. If you just multiplied them straight up, you would get that that arc is 540 units. There's no way that could be 540 units long if this right here is 12. All right, sector area formulas. Go ahead and copy these down into your notebook. But the way I just remember it is area equals the whole circle times the fraction that is shaded. So I don't really memorize these formulas. I just calculate what the area of the whole circle would be, and then I multiply it by the fraction that's shaded. Here we're going to see an example. So find the area of the blue slice. I want an area here. So if this 8 is 8 inches, let's just make it inches. Then I want square inches of blue. Okay, so do we remember this formula? Area of a circle equals pi r squared. This will get you the whole area. Let's go ahead and just plug right into this formula right now. Area equals pi times 8 squared. Area equals 64 pi inches squared, in this example. So that's the whole circle. Okay, now what fraction is shaded? Well, a full revolution, we should have this one memorized, is 360 degrees. What fraction of 360 is 60? We'll just set that up, 60 over 360, and simplify. This here equals 1/6. So now I'm just going to multiply these. So the whole circle, this is the fraction shaded. And 1/6, that makes sense. I can cut it into 6 identical slices to kind of prove that to myself. Yep, this is 1 of 6. So 1/6 of 64 pi, 1/6 times 64 pi equals 64 pi over 6. Divide the top and the bottom by 2, we'll get 32 pi over 3, and then we'll say square inches. Okay. And then this one you can plug into your calculator. It's not going to be as good of check for reasonableness. That's approximately 33.5 inches squared. I guess if this is 8 inches, I know an 8 by 8 cube would be 64 square inches. This looks like it'd be about half of that. Not as good a check, but that's still a way to check for reasonableness. All right, you've got a worksheet to try a bunch more of these, and have a good rest of your day.